Hi Penmoon, and this is our formal lab report for lab 1. So this is the determination of the molar volume of a gas. The purpose of this lab was to experimentally determine the molar volume of hydrogen gas and to compare it to the 22.4 liter theoretical STP value. To relate gas concepts learned, e.g. the combination gas law and Dalton's law of partial pressure, to previously learned concepts involving balancing chemical equations with relationships. Our introduction is that the water displacement method can be used to capture the hydrogen gas liberated when a strip of magnesium metal reacts with the 3.0 m solution of hydrochloric acid. The total gas volume of H2O vapor and H2 adjusted to the room's barometric pressure can be determined by the oedometer level in the large container. I totally skipped a line. Sorry, graduated gas measuring tube. By partially immersing the tube into a large container of water until the liquid level inside the tube matches the water level in the large container. According to Dalton's law, the total pressure in the meter is the sum of the pressure of the hydrogen gas collected plus the water vapor pressure. Symbolically, total is pH2 plus pH2 0, subtracting the water vapor pressure from the total pressure, which gives you the pressure of the dry hydrogen gas. Our hypothesis is if we combine magnesium hydrochloric acid, then the molar volume of hydrogen gas will be right around 22.4 liters per mole. Our procedure was that, number 1, a pre-measured amount, which is about 2.5 centimeters of magnesium ribbon, is accurately weighed, and if it's around 0.04, then it's accurate, which is the coil deflected to the stop end of the meter. Number 2, water is carefully poured into the meter containing about 10 milliliters of 3-MHCl, and the meter tube is carefully filled completely to avoid any airspace when the tube is stopped. The tube is then inverted into a 60 milliliter beaker of water where the empty strip releases bubbles of H2 gas as the ribbon solution diffuses downward and reacts with the empty. Number 4, the volume of the collected gas mixture, water vapor, and hydrogen gas is measured after ensuring the internal gas pressure of the meter is the same as the room's pressure. And you will know that if the gas pressure matches the room pressure and the meter is lowered into a large jar of water until the two liquid levels are equal. Data. The mass of the energy was 0.059 grams and the P room mmHg was 760.1876. The V meter is 63.8 milliliters. The T water temperature was 21.5 degrees Celsius. The T hydrogen temperature was 21.5 degrees Celsius, and the pH2O was 19.3 mmHg. Our results was that number 1, the mass of the magnesium used was 0.059 grams. The moles of the magnesium used was 0.00243 moles of magnesium. Calculation of partial pressure of H2 gas with P hydrogen is equal to P room P water vapor. The P hydrogen was 760.1876 negative 19.3, and the P hydrogen was 740.89 mmHg. When the liquid level inside the meter matches the surrounding water level in the jar, the total pressure of the gas inside the tube equals the outside pressure of the classroom. P ATM is equal to P total, which is equal to P hydrogen gas plus P water vapor. Therefore, the P hydrogen gas is equal to P ATM minus P water vapor. 4. Calculation of experimental volume is pure in dry H2 at STP. Use the combined gas law where P1 and PV and V1 refer to the original classroom conditions and P2 and V2 refer to the desired STP conditions, which is the conditions are listed here. And then there's the STP conditions, which are also listed down here. And the calculation of the mole was produced in a chemical reaction, which is this. And our hint is to use the circles to plan your calculations in mole of expected H2 product of the number of grams of magnesium that you started with. MgS plus 2HCl, AQ, H2G plus MgC1L2. That was our formal lab report for lab 1.